and so 4 of them come up every year. So next year will be the other 4. So this year, who's up is myself, Jerry, W0GV, Kevin, K0 KPS, who's our vice president, Kathy, N0CRZ, and Jan, WY0J. Kevin, myself, Kevin, and Kathy have all agreed to continue on, if so re-elected as far as being a board member. And I'll explain too. We do the board, and then we have to elect the officers from the board. From the board, excuse me, got a little rough throat tonight. Jan had indicated that he would vacate his position if somebody had an interest in being on the board. And I'll say that Jan's been a real valuable board member. He's served several terms, and he's always had the DRC in his mind, and so we thank him for that. Mark Thomas, who you meeting here this evening. I don't know where you went, Mark. I know you're there somewhere. We've got about 33 people on it, looks like. But anyway, Mark indicated that he would like to take a board position. And, because of COVID and all, we haven't had meetings for nearly 2 years. So just a little background from me, for Mark, and then if he wants to say something on his own behalf, well, that's great, or in his defense, whatever it is. But Mark's helped us with a lot of stuff at Station 4, getting our power switch up and running, and he's provided us, we were getting internet from the fire department, and that never did work very well. So he's provided us high-speed internet, which we bring over on our microwave, and that enables us to make our wires X work like it should, and make our power switch work. And then I guess the most recent thing was, we've had, any of you that our 6 meter gets on our 6 meter repeater, we've had the noise that we have problems with at Station 4 for years, and so he provided a spot for us to put our 6 meter remote receiver, and that's really making our 6 meter a real performer now. So I invite you to, if you got 6 meter FM equipment, check in on Sunday morning, 10 o'clock on we call it the 6 meter invitational net. We used to have 5-6 check-ins. I think last week we had 14, so the repeater's working really well, and people can hit it with low power. And then finally, I think Mark arranged our field day location. And if you were at field day, you probably met him. He had the little trailer, which I think he's sitting in tonight, up in the northwest corner up there, and he arranged for us to get that site. So if you could arrange to plant some trees for next year, Mark, that'd be really good. But anyway, the site worked out well, so we thank him for that. Anyway, I will see if Mark wants to say anything, and then I'll open nominations. And anything you want to say in your for or against yourself there, go ahead.
My defense, yeah. I appreciate it. I appreciate you thinking about me. I enjoy working with the club. I've been looking at several of the different clubs, and the people in this club are just awesome, and they really have passion about it. So I'm happy to be involved in any way I can, and if I can provide any more help or bring some of my knowledge and my resources to bear, even better. So I'd be honored to help.
Okay, well, thank you, Mark. Alrighty, so I will open nominations, and I was briefing a little bit on Robert's rules today, and so I can nominate. So I'm going to open nominations. I'm going to nominate Mark Thomas, N0XRX, and say that nominations are open.
I second the nomination for Mark Thomas.
Okay, thank you. We got a second. Yeah, nominations are open. Any other nominations? Nominations are open. Any other nominations? Hearing none, we will close the nominations, and
Mr. President,
guess-
can I make a motion for acclamation?
you sure can.
So the incumbents, 3 of the incumbents are willing to serve again, as I understand it. And we have a nomination for the 4th open position. So I move that we, if there's no objection, accept all of those by acclamation.
I second.
Okay, I guess we'll say anybody not in favor, because I don't know how else to do it here. And hearing nothing, that's accepted. That's not the right word. But anyway, and thank you to Mark. Thanks for all the other board members for that. Now what we have to do is elect the officers from the board. So I'm president, W0GV. Kevin is the vice president, K0 KPS. Kathy's the treasurer, N0CRZ. And Orland's the secretary. He's not up for election. Neither is Jim Beal or Jeff. They'll be up next year. So I guess a motion's in order to either elect like we are or make any changes.
Mr. President, I understand the incumbents are willing to serve again in their positions as officers, and I move that we accept that as by acclamation.
Okay.
Larry Irons seconds.
Okay, Larry, thank you. Any opposition to that? Hearing none, motion's carried. So I'll just say thank you for your confidence. We've got a good board. Mark will be a great addition to the board. We've all worked well together over the years, and that's really important. I think we've covered a lot of ground. And sometimes, I work for the federal government, so, sometimes I kind of relate us to the federal government. We usually get it done, but it sometimes it takes a while. But anyway, that being said, thank you. We will move on. We will have our drawing later in the program for the $25 gift certificate. And I cannot think of anything else that is newsworthy to put out to the membership at the moment. We're fighting the battle with, I see Orland there, we're fighting the battle with Bridgecom on our 220 repeater, and hopefully we'll have it back in. We won't go into any details on that right now, but anyway.
Barbara has a hand raised there, Joy.
Yeah, we're at. I'm sorry? Mark?
It's in the people part.
It's
In the people?
Yeah, but look at the people. She's at
Oh,
the top.
okay, I'm not, well, let's see, I don't find the people part. Who's got their hand?
I'll just speak. I can't remember how to sign up for the drawing.
Okay, Barb, I see you there. Mark will send out, Mark will put not Mark, I got Mark on the brain. Jeff will put a link in the chat a little later. You just click on the link, and is that all you got to do, Jeff? Click on the link and put your name in, or?
That's correct.
Yeah, so the link will come up he'll tell you when he puts it in the chat, and you just click on it, and that'll put you in the drawing.
Thank you.
So, okay, that's probably a good thing to bring up, because we've got a lot of new people. So, okay, without further ado, I guess we will move on to our program, and I think this is going to be somewhat different here. We're going to be talking about, and I got my wrong paper. I printed off the thing, and then let me go over to our website real quick, and if it'll come up here for me. W0. Okay, we'll get that up on what I did with what I printed. Anyway, we're going to a presentation about RF and earthquakes. So I think this will be real interesting how it correlates. And we got Alex Schwarz, VE7DXW, and that's our presenter. And let's see, I know you're in British Columbia. Alex, you're gonna have to tell us where you are and a little bit about yourself. And I won't even attempt to go any further than that with what you're going to present. So with that, I'll turn it over to you, sir. And thank you. We typically we go 45 minutes, not more than an hour, if you would. And you got it. Everybody, if you're not muted, please do so. I'll do that myself right now.
Okay, I'm unmuted now. So my name is Alex Schwarz. I studied communication, electronics, and engineering in Austria, and I moved to Canada in 1990. And I was always into ham radio. I was already a ham radio operator just before I finished my studies, and I just love ham radio, and I think it's a great way to communicate. And even with the internet, the communication via the shortwave radio is still a lot of fun. And thanks goodness to the digital channels, because the digital channels are so busy that they allow us to build a RF seismograph, and we're going to go to that later, that can detect earthquakes. So what happens is the digital channels on the shortwave radio bands, we monitor the 80 meter, the 40 meter, the 30 meter, and 20 meters, the 15 meters, the 10 meter band, are so busy that when there is an earthquake, propagation will pop up, and we can measure the earthquakes and the propagation at the same time. We get the measurement of the earthquakes from the USGS, and the earthquake, the propagation data is collected by the RF seismograph. And I think we should go into the presentation. So,
We got you as raising your hand, not presentation there.
I got just a second. I'm just gonna allow this. Okay. It's okay. And hold on. Just bear with me. I'm just gonna bring up the. Okay. Where did I put it here? Sorry for that. I'm sorry for that. I was just trying to figure where to put that PowerPoint presentation. I have it here. Oh, here. Sorry for that. There it goes. Where is it open? Oh, there it is. Just come on. Sorry about that.
I think you want to click on slideshow, don't you?
Yeah, well, I'm just trying to open up another slide. So
Okay, now we're seeing something.
yeah, it's the wrong slide. So open. Okay. Sorry about
I've
that.
got I've got the PDF, Alex, if you want me to drive and do it on my side.
No, I should be able to do that. So,
Okay.
Come on. Okay. I don't know why it does not open this. I had it open before. That's just a second. Let's go back.
Alex, this is Larry. Try right clicking on it and then it'll pop up and you can do open.
Okay. Okay. Yeah, that's okay. Yeah. Okay. Open here. Open with Microsoft PowerPoint. There we go. Oh, there it goes. Thank you. Ah, but it's the wrong presentation. Ah,
You want me to just go with the PDF on this side?
yeah, I think so. What something is my computer is not. Oh, okay. Okay. Yeah, I guess we have to go with the PDF. I don't understand why it's not doing it.
Because we're trying to do it during the club
Yeah.
meeting. It always happens.
So, okay. 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 One more try. One more time. Okay.
I think we'll just go with the PDF. We can.
And Jeff,
Okay.
that seems to be cut off.
Yeah, I know it's the way it came across.
Mm-hmm.
The other slides look good after that.
I just try it open. I had it open. I think my computer is just not doing what it's supposed to. I think it's overloaded with the. Okay. No, that's not working. Sorry.
That's all right. The PDF will work fine. I think everybody can see it.
Okay.
This first slide is kind of jammed to the left, but the others look
Yeah,
better after
okay.
this.
Okay. Okay. How are we going to do this? Am I locking? I'm going to stop sharing the screen.
I've got the screen now and I'm presenting, so you just tell me when to move.
Okay. All right.
Just say next slide.
Okay. All right. So this is our first slide where we discuss the new way we have to detect earthquakes, and the way to detect earthquakes is not through a mechanical motion. It's through the change in the HF radio bands. And you could go to the next slide, please.
Oh, that's not good.
No, there's the, okay, so this is the current measurement where we see an standard RF seismograph, do the measurements. And it's a very old way of detecting earthquakes. And unfortunately, we have detected earthquakes. We can detect earthquakes via changes in the propagation. And this is what the RF seismograph does. Slide, please. Okay, and the way this happens is by the earthquakes create electromagnetic fields. The electromagnetic fields are created via piezoelectric effect and the crust. And there's a lot of crust. And as the moon moves about the Earth, it brings the tide. The propagation changes because the stress of the electromagnetic, the stress of the continents and which creates electromagnetic fields. And well, we had this. We were talking about this propagation without the sun. The interesting part is that we find using the RF seismograph that the sun is only a second choice of propagation. It always seems to happen when there is an earthquake. So if we have two small earthquakes in the range of 4.9 to 4.3, 4.5, we would be able to see that the propagation changes, and we'll show that to you later. And the most interesting part about this is that instead of the sun, it's actually the moon that creates the tectonic movements, which allow the radio waves to change. And this is the propagation we see and can measure. Next slide, please. Okay, here is the history. This is the first graph that I found was done in 1936, and it displays telluric currents. And the telluric current is nothing new, and we just haven't thought about it. And we think in our new idea we're focused on the sun, and we can forget that there's a lot of electricity that is moved around in the ground, and all this movement of the electricity creates electromagnetic fields, and this can be measured via shortwave radio, via the RF seismograph. The RF seismograph is a special tool because it is not just specializing on one radio signal. It's listening to all the radio signals in the world, and so if there's the slightest change and in propagation, the RF seismograph will pick it up, and we'll see later what kind of equipment that is. It's just a standard RF radio. And what's also interesting is the way Earth is constantly pulled and stretched by the moon. So this is additionally creating electromagnetic fields. And these microfractures are released in rock and create, again, magnetic fields. And we found that there's actually something interesting happening with that, is that a lot of the ham radio operators are living near earthquake zones. So if you have if you have a break in the earthquakes, there is a way for a break in the continental plates. You have a chance for the magnetic fields to come up easier, and we have actually several of these inactive rifts here in British Columbia, and especially where I'm living in. And it seems like propagation is just really good when you're near a magnetic fault line. Next slide, please. Okay, so this is another view that I came up with, and this is kind of like how the magnetic field lines come out of the ground on an earthquake zone, and they affect the ionosphere. And this is also something that we measure with the RF seismograph. So we see these jitters, that is rifts and shock waves that are created by the electric fields, and this shock wave can last a couple of minutes to a couple of hours, and that's the kind of propagation that we're actually getting right now. It's never continuously. There's always an earthquake or two that either create or undo propagation for the location at the RF seismograph. Could you please do the next slide? Okay, so this is now we're gonna tell you how the RF seismograph works, and It's really true that earthquakes do disrupt propagation. There was a 7.2 earthquake in Los Angeles not too long ago. Not in Los Angeles directly, but in one of the valleys behind it, about 200 kilometers away from Los Angeles. And I think that happened about 3 years ago. And the radio propagation was really dim that way. The RF seismograph was actually developed as a tool to measure the changes in the solar eclipse in 2017, and the RF seismograph started running in 2016. So we have accumulated a lot of data, and that has been kept, and we will make it accessible to people that are willing to look for the link between propagation and the our seismograph, the propagation, and we hope that we can one day put it in the database. So please, next slide. So here is we all know the if anybody that uses shortwave radio knows that shortwave radios are really doing something strange. They refract by the ionosphere, and this creates the perfect tool to measure the changes in the ionosphere that created by an earthquake. We found having our seismograph running in Lynn Valley in North Vancouver we found that the best earthquakes we detect are the ones that are on the horizon of the antenna, and we also found which really found that strange was that small local quakes. Like there's a lot of quakes that occur in Los Angeles, in California, and along the coast, and all along the Ring of Fire, where we can pick up a lot of quakes. And the smallest quake that we picked up from Europe was a 4.2 in the Greek islands, and that was amazing that we could pick that one up, 4.2 from the Greek islands, and it definitely changed propagation. And as we see, our seismograph is a global tool utilizing 10,000 or 100,000 different radio stations that transmit the signals so that we can pick it up. So our seismograph is not just one radio station. It's basically all the ham radio operators that are broadcasting their digital signals. Next slide, please. And here we have the way we envision the earthquakes come out of the ground. So we have the subduction oceanic ionosphere, and it's pushing against the continental lithosphere, and it's vibrating there. So this vibration causes the piezoelectric continental shelf to become electric, and we have magnetic field lines that pop up, and again where you have a rift, you have a chance for the earth of the magnetic field lines to come up easier. So there is a permeability factor that the ground is very tough for magnetic field lines to get through. So they're always looking for a way to get out easier, and the energy is dissipated that way. And the tectonic plates are always vibrating. We have a measurement from the U.S. Geological Survey that we always use in our measurement. The USGS record thousands and thousands of quakes a day. Like they're all below, like most of them are below a level that we don't notice, but they're there. And I think that was the biggest eye opener for me is that this energy is always there. So can we have the next slide, please? And yeah, this energy, when we look at the globe, uh, uh, it's actually, I think that we need to rethink the way earthquakes are benefiting the Earth. You see, we have all these little quakes that we see on the globe, and they create a lot of energy, but it's all small energy. So what happened is that's like a back pressure from the solar wind. So the especially here on the side of the planet on the day side, you can see how the earthquakes are pushing against the ionosphere, and they actually keep the ionosphere at a certain level. So this is happening all over the planet. So in my research, I think that it's actually the earthquakes that make it possible for the ionosphere to stay up high enough so that that life can exist on this planet. And when we look at the night side, you see the earthquake have a bigger impact because the pressure is relieved from the sun. There's no solar wind. So like it is definitely affected by the solar wind, but it's the earthquakes are the ones that have the closest uh, effect of Earth because they're right there. We're living right in the earthquake zones. Next slide, please. And there's another picture of how I envisioned that how radio signals change. This was an earlier picture, but I think it's still pretty valid. Like we have an earthquake zone, and we have the current rotating, and as the current rotates, field lines pop up, and then the ionosphere thins out, and that's what makes radio propagation possible. So as the dome creates a lensing effect, it bounces back the waves the way we can receive them. Can we have next slide, please? Okay. All right. So I'm gonna give you the updated uh, uh, PowerPoint, and then you can print it out. This is a slide to show. Unfortunately, it's a little bit cut off, but it shows the way a propagation changes over time with the RF seismograph. Periods of enhancement and attenuation, and these periods are like happening 3-4 hours a day, and then it's attenuating, then 2 hours a day it's attenuating, so it changes constantly. So and this change can only be explained by earthquakes. So if you go on this slide at the 1200 hour area where we have an enhancement, they see the green area where the 40-meter band comes up, and at the same time we have these earthquakes at the bottom that push up the ionosphere and create the propagation in the process. And this is not something that happens once a day. It happens like once in a blue moon. It happens every day. You can follow this every day. So that's the RF seismograph, and we developed the RF viewer. But you see here the graph is created by the RF viewer, and that is created at a daily basis. And we posted information on our IO user group, which is going to be later in this propagation. Can you show next slide, please? Okay, so now we're going to come down to the radio part. Okay, this is a an FD990, which is a really, really nice radio. I love it. I have it as a second-hand radio, as a second radio to my main radio. My main radio is a Kenwood TS590, which has a beautiful receiver, and it's connected to the RF seismograph via the IF interface. We in order to make the RF seismograph read the RF signals at a really, really precise level. What we do is we take the IF out of the receiver, and we convert it down to 12 kilohertz, and then put it into a very accurate sound card, and this allows us to create these images that are not possible to get from the radio otherwise. And we have modified a lot of different radios that could be used for this kind of research. And unfortunately, can I have next slide, please? All right, so this is a little bit of a more of a down to earth graph that I want to show you. What we first discovered before we had the big RF seismograph display, and it's mainly little things, like the you can't really see that, unfortunately, but you can see that earthquakes create earthquakes create noise changes and propagation changes in the RF seismograph in the propagation. And when you go here to H to the purple, that's the 20-meter band, and the 20-meter band pops up. It's usually done through small quakes. Can we have the next slide, please? Okay. All right. So how does the RF seismograph operate? So I'm lucky to live right at the Ring of Fire on the Pacific coast, and it allows me to see a lot of earthquakes. And interestingly enough, Hawaii is just in the right position for me. It's Hawaii and the South Pacific. Sorry, not the Sun. Cuba. It's Hawaii and Cuba that are the strongest affecting my measurement of the RF seismograph. It just seems to be there's some sort of a sweet spot where it's like 2,000, 3,000 kilometers away, and it just seems to have the biggest impact. As Cuba and Hawaii. That's at the RF seismograph. And what we want to do is of course we would like to see more RF seismographs. So right now we're only making decisions or making it possible to say, okay, well, this is a reasonable way to see the changes in the ionosphere created by earthquakes. There's probably if we could have and a lot of these signals that I see in the RF seismograph, there is precursors. So if you would be able to have let's say 5 or 6 radio stations, RF seismograph radio stations on the Ring of Fire, we will be able to triangulate the signal and possibly come up with a way of pre-detecting earthquakes. And I'm saying it seems like it's possible. It's just what I want to say is that an RF seismograph costs maybe $10,000 to set up per station, and that's probably high. Considering putting in an antenna, getting a big antenna and getting the station, it's have a setup, and get internet connection. You need internet connection, and you know, like if you think about it in terms of measuring earthquakes, $10,000 is nothing. It's cheap. Next slide, please. Okay, so that's what we would like to do. Everybody, then like people come together and put up more antennas. And what we like to do is if somebody has an unused receiver or unused equipment, you know, like we could maybe use it as a RF seismograph, turn it into an RF seismograph, and then measure the changes in the ionosphere, which is already very interesting without the connection of the earthquakes. Next slide, please. Okay, so here we have the way the first idea that I got from that is something that earthquake change propagation was the Scientific American earthquakes in the sky earthquake in the sky article that was done in 2018, and I was talking to Scientific American to get more of these stories into the Scientific American, and they don't want to post any more stories. I think there's a real disconnect between scientific reality and scientific measurements. So what we're gonna do, what we find is that that every time there's a measurement that indicates you know, earthquakes are not only mechanical. You know, it seems like people get ridiculed or people get shut down. You know, it's just a sad thing. You know, like it's just like we should be able to talk about this. You know, like it's just it's amazing that I'm the only person that can see these earthquake signals. You know, isn't it time that we expand and say, wow, this is really interesting. Well, maybe we should see that somebody else can do the same thing, and then, you know, like it's like breaking a barrier. It's almost like you know, there was a satellite called Image. I don't know if you noticed. It was an amazing experience to watch the solar storms in the ionosphere, and then all of a sudden in 2008 the satellite went black. And the reason it went black is because they discovered the connection to the earthquakes, and they didn't want to ridicule, or they didn't want to take away the scientific significance of this satellite when the far ultraviolet measurements that they took. They just disabled the satellite, and that's still up there. And in 2014, another satellite was launched. This satellite is called ICON, and it was built in California at the university. But have you ever heard of ICON? That is, it's like I didn't know about it. I found out about that 3 weeks ago, and it also has the same far ultraviolet measurement camera, and it just it doesn't seem like there's, as soon as we experience earthquakes creating anomalies, we're just putting a blind eye to it. So there's a lot of research, and probably a Nobel Peace Prize if somebody can come up with this idea that earthquakes are electrical. Can I have next slide, please? And yeah, this is the sad part. Our earthquake response is still gathered on after effects, after effects, and it's not be done like it could be quite different if we get together and look at the RF seismograph and the possibility of detecting earthquakes before they happen. Okay, it's another slide. I think that's the last slide. Oh, that's okay. That was it. Okay, any questions or? Oh, put up the drawing. Yeah.
Alex, I'll do that. I just have a question. You know, the USGS National Earthquake Center is here in Golden, Colorado on the Carter School of Mines campus. And I'm just curious as to whether anybody's proposed any type of funding for a study of this, or is this in its infancy, or what do you expect will happen?
Well, I was contacting the geological departments in at the University of British Columbia, and there was no response. They say it's you're a lunatic. Like it's just this is not happening. So there's something there. Like I'm sorry, you can like I like if you want to join our user group, we can show you the data, but it's not the data is not as clean as we would like. There's a lot of different ways of earthquakes making propagation, and it it is just but it's the earthquakes are the only thing that there's no man-made noise that creates propagation. And since we measure propagation, the earthquakes are for the signals are for real. But I
Yes.
definitely would appreciate if anybody, like if there's another university that's open to this, I I I drive down there and I help you set it up.
Can you hear me?
Yeah.
Yes, I lived in Japan for 3 years and talked to a number of researchers there, and their theory was that when there is subduction, that crystals grind together and they generate electric fields. And we could always tell there was going to be an earthquake because dogs would howl, the birds would go crazy, and fish in fish tanks would crash against the sides. I don't know if you've talked to the Japanese about this. They're experts.
Well, I was talking to the Japanese radio manufacturers to see if they would implement that or take that on as part of their research project, and I was shut down because they're interested in selling as many radios as possible. And if you sell radios with the sun creating the propagation, you sell a lot more radio in their mind. So if you sell quick radios that propagation is created by earthquakes, that would not sell a lot of radios in their mind. So it was not taken on. It was more like, oh, another crazy guy.
Orlin, who could we hook him up with on Mines campus? I'm sure there might be a graduate student or two that might be interested in looking at this.
Yeah, like I have all the data, and I also created a video on which I posted on YouTube about the quakes of the last year. So there's like a slide every one day per slide. It's every 10 seconds, and you look at it, and you can make up your you can see that there's earthquakes, but I would say it's hard to like my opinion is that I get that earthquakes are the only thing that create propagation, and that's what I get from the our seismograph, and the sun is just setting up these points. So when the sun comes in and you have solar wind blowing against the sun, this creates earthquakes, and I have several earthquakes larger earthquakes that are created that way. And the earthquakes create a gap in the ionosphere, and you have more propagation.
Alex, Orland Wolf, who is one of our directors, is here in the meeting, and he works for the Colorado School of Mines. He said in the chat that he would check with the geophysics department there and see if there perhaps might be any interest. I also know of a woman there that is looking for student projects, and I can connect you with her, that she might be interested in something.
I appreciate that. Yeah, that would be great. Yeah, I think that would be a really big step forward to have a second institution take on this as a project, because like, I don't know how long I can keep up keeping up like fighting a fight that I at times don't think I can win.
Well, there's some pretty incredible people there. Years ago, I worked for USGS for the branch of uranium and thorium, and the National Earthquake Center is in the basement of that building there in Golden. And I'm sure we can find some smart people that might be interested in looking at what you have.
I would really appreciate that. We could maybe if it comes with the right from the right source, like if I approach university, like I'm a nobody, right? So if it comes from somebody that says, oh wow, this is really happening, look at this, and then we could maybe then it's probably more appropriate, and then they're more open-minded to it is strange, like I say, when I first realized that I see earthquakes, it took me 3 weeks before I was able to say, oh no, okay, well, this is really true. This is really what's happening. Like it is we just say it's mind-boggling, right? It's just something totally unexpected.
Okay, well, thank you, Alex. That's very interesting. Maybe it's something, I don't know. I say with the club, we could talk about this, and the university or mines. That's a good source.
So we've got 7 folks that have entered the drawing.
Yeah.
Anybody else want to get in before we?
Yeah, go to the chat if you want to get in the drawing, and you'll see Jeff's link. I'll give you a second to go in there and click on it.
Okay, I guess I'm gonna leave now, but I appreciate it. And if you could send me the link of the presentation, that would be great.
Okay,
I sure will.
Jeff will do that. Okay, thank you, Alex. That's
Thank you very much.
Very interesting, very different stuff. So
yeah, it is. It's really strange. Thank you.
All righty. Well, thank you very much. Anybody hasn't gotten the drawing that wants to? What do we got now, Jeff?
We're up to 12.
Up to 12. Okay. Larry says he's in the geophysics department, so there you go. Direct link. I wonder what it takes. I didn't quite understand everything, like probably some of you. I don't know where you would put a receiver, but that could be. Guess you need more information, really. And Larry says Dr. Hebrew Bozdad is a global seismologist. That's a mouthful. That's good. Larry, is that something you do, is get a hold of him? He also does Mars. Okay. Yeah, well, anybody for the drawing? Anybody else?
13. No, there's been nothing.
13. Anybody else? Anybody else? Last call for drawing. Give it a second here, and then we'll spin them up. Well, 13. We standing at 13.
We got 14 now.
14. All right. Anybody? Want to wait too long here? We're coming up in just about an hour, so. Okay. Still at 14?
Yep.
Okay, roll them.
Okay, let me get the spreadsheet up here. And
Stir them up.
okay, now it's randomized and Daron popped out on top, K1DBC.
Okay. Jerome, where are you? You still here?
You hear me?
Okay, you're the lucky winner. So
Perfect. Appreciate it.
great. Kathy will send it off to you here probably tomorrow. So,
Well deserved. Thanks for all you do for the club, Daron.
yeah,
Cool. Yeah, my
really,
pleasure. Yeah.
very, very much. Okay, everybody, thanks. Congratulations to Mark and the rest of the board. We'll look forward to another productive year. So thanks, everybody. We'll close it out. 7-3.
See ya.
All right. Thanks everyone for watching. Yeah. Just won a $25 gift card to Ham Radio Outlet. I'll probably pass that along to the to the Learning Net. So appreciate everyone.